I will take another example, that is, I want to build a toy which is consists of two shapes or two solids. One is a cone, another one is hemisphere. So I want to build a toy which has two shapes or two solids. One is a cone, another one is a hemisphere. So what I will do is I will just draw a cone. So this is my cone and this is my hemisphere. So what I will do is, this is my cone and this one is my hemisphere. I'm just going to combine these two to form a toy which is looking like this. So this part is inside the this one, so I will just make it as a dot dot dot. So this is not visible, this is inside the things. This is what we are going to see it. So when I look at this solid, the toy which we formed, if you see it, the circle area of this cone, that is this part, is getting immersed or combined with the circle part of the hemisphere. So if I take a cone separately, then I used to find out the total surface area. But I want to combine these two, that's why this part will be immersed with this part. I'm going to find out the curved surface area of this, and the curved surface area of this, and we are going to add this to get the total surface area of the toy. So what I can write is total surface area of toy is equal to curved surface area of cone plus curved surface area of hemisphere. So once I find these two curved surface, I can find out the total surface area. So next topic which we are going to cover is volume of a combination of solids. Volume of a combination of solids. So first we studied the total surface area of the solids. Now we are going to find out the volume of the combination of solids. So again, I'm going to take the basic example, that is the tanker. Just remember, if I want to find out the total, the volume of this combination, that is, it has three combinations again. So it has a cylinder, it has a hemisphere. This is also having another hemisphere. So when I want to find out the volume of this, remember all the circles of the cylinder as well as the hemispheres will be considered, because that particular part is present in the solid. If I want to fill the water in this particular shape, then that circle is also getting filled up. But it is not the same case in the surface area. What we use, what will be done in the surface area? The circle part which is inside the tanker is present inside, and that is circle part is getting immersed or combined with the hemisphere. So that particular part will go off. But while finding the volume, that particular circle part will be considered. So if I want to find out the volume of this complete shape, then I want the volume of tanker. If I want to find out, then I have to consider the total volume of cylinder plus total volume of hemisphere into 2 as usual, because there are 2 hemispheres. So next topic is conversion of solids or solid from one shape to another shape. So it is again an easy topic. There is nothing much to study in this. So I'll keep it very simple. So in the previous, when in 90s and all, we used to see only one type of candles, that is a straight, a cylindrical shape candle. So it was like this. Okay, now the era has changed. People want the candles of different shapes to decorate their homes at the time of Diwali and all. So what I will do is, I will take the candle, first I melt it. The liquid what I get, I will take it in a container. After melting, I will get the liquid of wax. So this liquid what I got, this what I got, what I will do is, I will take another shape. Say I will take a shape of a diya, a shape of diya. Okay, so what I will do is, I will just take all these liquids and pour it in this diya. So when I pour it, the complete liquid, I'll just pour it in this diya. So the candle which was in the cylindrical shape, now it has been converted into hemisphere. But remember, the volume, the volume of this cylinder, when it is melted, it is same. When it is converted to another shape, is again it is same. So what is the main thing in this particular section is, if I convert any of the solids into another shape, then the volume remains same. The volume remains same. Hope you understood all 3 topics. One is total surface area of a combination of a solids. Second one is volume of combination of solids. Third one is conversion of solid from one shape to another shape. So after completion of these basics, the last topic which is there in your syllabus is frustum of a cone. So I'll take a new page because it requires some explanation. So frustum of a cone. So I'll just draw the cone and then I'll start the video. So this is what the cone I just drawn it. So first we'll understand what is this frustum of a cone. So frustum of a cone is when a cone is cut in such a way that the spot where it is getting removed is just this particular the part which has been removed is just parallel to the base of the cone. When I cut this cone, I'll cut this cone in such a way that the cutting part, that part is completely parallel with the base. So what I will do is, I just cut this cone at this particular area or particular point. When I cut this cone, the part I'm going to get is, so this part is a smaller cone, and this remaining part is called as frustum of a cone. So this is the frustum of cone and this one is a smaller cone. Now question arises, how can I find the area, surface area of this frustum of a cone or volume of this frustum of a cone? So find out the surface area or volume of the frustum of cone. Let us start digging up what all things I will get it here. So if I look at this particular cone, I'll just name some things here. This point I will going to name it as O, this I will name it as AB, and sorry, this I will name it as P, this I will name it as O, this I will name it as C, D, the points where the cone is cut, and this particular point which I'm going to name it as Q. Now in this, the radius of this cone, I'm telling the complete cone, the base of the cone is R1, and the radius of the other end of the first or the cut part of the cone, after cutting the part I'm going to get another radius, that is I'm going to call it as R2. And here so this particular height of the cone I'm going to call it as H1, and the height of the another cone I'm going to call it as H2, and the slant height of this smaller cone I'm going to call it as L2, and the slant height of the bigger cone I'm going to call it as L1. So these are the nomenclatures which I just did for my convenience. So okay, so this is what I nomenclatured. Now let us, I told you I want to find out the total surface area of this frustum. So to find that, let us find this R2. R1 they have already given. R2 I don't know. The slant length I don't know. The height of this I don't know. If I came to know all these parts, then I can easily find out the area of the frustum. So to find out all these things, let us understand how it is being built. So if I look at the two triangles, one is triangle OPB and triangle OQD. In these two triangles, the angle ODQ is equal to angle OBP. Why? Why both are equal? If you look at this diagram, the part which is been cut is parallel to the base. Okay, it is parallel to the base, and the angle with respect to this base, that is this one, this I will call it as theta 1, is same as the angle which is formed with respect to this parallel line, because the slant line is same. This particular line is parallel to this, that means this also same as this. So the angles are same, and this angle is also same for both. This is theta 2, because for this triangle also the same angle, the O is considered, and for this triangle also this angle will be same. When, and this as usual, this is also 90 and this is also 90. So what all things are there? This angle is same. Another angle is POB is equal to QOD, and angle OPB is equal to angle OQD, that is equal to 90 degree. All the angles are same. That means what I can conclude from this is, I can say that my triangle OPB is similar to my triangle OQD. I am telling similar, they are not same. Telling similar. That means what I can say is the sides of these two triangles, that is OPB and OQD, are in the same ratio. Are in the same ratio. That means OQ divided by OP is equal to OD divided by OB, that is equal to QD divided by PB. Okay, so my angles are equal of the both the triangles. Then I can say that my sides of these triangles are proportionally same. Then this particular what I just told you is called as AA criteria. This is AA criteria. So what I can say from this is my OQ means from the diagram OQ is it's H1 by H2 is equal to R1 by R2 equal to L1 by L2. So the ratios of these sides will be same. So if I know the height of the cone, if I know the height of the radius of the cone, if I know the slant height of the cone, then I can easily find out height of the smaller cone, radius of the smaller cone, and slant height of the smaller cone. So once I find out the total surface area of cone and surface area of bigger cone, bigger one, and surface area of cone which is smaller, which I get it after cutting the cone, then I can find surface area of first term. How can I do it? So bigger cone minus smaller cone to get the first term. So how can I get the height, radius and the length of the smaller cone? By using this AA criteria. So this is what the theoretical part of the first term. Still, if you want any queries, please ask. You can WhatsApp me or you can comment on my in the description. You can comment in the YouTube. Thank you.